Alright, page 4. Distance from A to B and the coordinates of the midpoint of AB. And there are lots of different ways to do this. The formula is going to be the most common way, so I'll just throw those up there and then push the answers on it. We've got let's do distance first. I've got negative 4 minus negative 2, so my x's, and then we're going to square that plus the difference in my y's. So I've got 3 minus negative 1, and we're going to square that, take the square root of that answer. So we've got negative 4 plus 2, so negative 2 squared would be 4. Then we have negative 3 minus negative 1, so it's negative 3 plus 1 squared would be 16. So we get the square root of 4 plus 16, square root of 20. We're going to dump that into simplest radical form. I've got a 4 and a 5. 4 breaks down into some 2's. Grab the set, they pair up. So I've got a 2 that goes on the outside and a 5 that goes on the inside. 2 square roots of 5. Midpoint, to show the formula, we've got negative 4 plus negative 2 over 2. This will be my x value. And then I will have my y value 3 plus a negative 1 over 2. So for my x, I've got negative 4 plus negative 2 is negative 6, divided by 2 is negative 3. Then I've got 3 plus negative 1 is 2, divided by 2 is 1. Alright, this one. Given the coordinates of an endpoint A and midpoint of AB, find the coordinates of B. This one, I'm going to show you the way I like to do it because it's just more fun that way. We're going 6 units, or 4 units rather, from 6 to 2. Going 4 units from 6 to 2. That gets us to the middle, which means we're going to go 4 more to the final endpoint. So we go 4 more away from 2, we get negative 2. Same thing for the y. I went up 8 to get there. I'm going to go up another 8 to get to 12. And that's going to be the other endpoint. Just thinking about it that way. The other way to do it, of course, is by using the formula. I've got 6 plus some unknown value for x over 2 is equal to 2. So my first endpoint plus my second divided by 2 is equal to 2. My y, same thing. I've got negative 4 plus some unknown value for y divided by 2 is equal to 4. And from there, you solve, you will get the same numbers. But that's the way to do it using the formula. 38, this is a great example of where the distance formula comes from. I'm going to show you it's just the Pythagorean theorem, so we'll just scratch out that triangle right there. When you've got it on the grid, one of the cool things is you can just count 1, 2, 3, 4, 5, 6. This is a distance of 6. This is a distance of 8. If you know your Pythagorean triples, you know that this is going to be a distance of 10. If you don't, 6 squared plus 8 squared is equal to some unknown number. We take the square root. You'll notice it looks just like the distance formula. Pretty fancy. Pretty fancy. So you'll get that same answer if you go about it using the Pythagorean theorem or the distance formula. However you want to do it is fine. But one of my favorite ways, on the graph, mark it down, see if it's Pythagorean, fit the triple. Now for the midpoint, I'm going to calculate it by hand. This means I will need to give my points. So I've got 4 plus negative 2 over 2 for my x's, and I've got 6 plus negative 2 over 2 for my y. 4 plus negative 2 is 2, divided by 2 is 1. And then 6 plus negative 2 is 4, divided by 2 is 2. And if you look at it, 1, 2 should look like it's right in the middle of your line, and it does look like it's right in the middle of our line. There it is right there. Sliding it up, use the protractor to find the measure of each angle. Here's my handy protractor. Now before I attack this problem, I'm looking at the angle. It looks like it's more than 90. So when you do your protracting, or you do your measuring rather, and you set it up, your answer should be more than 90. So this is going to be 138. If you said it was 43, something's wrong. Alright, 43, if you were to draw an angle of 43, it would be somewhere over in here. That's not what we're doing. We're trying to find the measure of this angle. You know it's more than 90. So when I give my two options, regardless of whether or not you know it opens up this way or that way, when you've got your two options, your angle should make sense. In this case, 138, we know it's going to be big. This one, as a counterexample, we know it's going to be smaller than 90. So when I take and I measure this angle, I'm looking for the number that's smaller than 90. Got it measured up. I'm going to say it's 45. That's a pretty good measure. Plus or minus a degree, depending on who you are. The next page is going to ask us to bisect that angle, so we're going to go back to this. Now, bisecting the angle is pretty easy. The first thing we're going to do is we're going to draw an arc that gives us 2 points that are equidistant from our vertex. So I put my little dot on the vertex. You'll notice very light lines. I'm not having to make some really huge lines. But I get an arc. These 2 points are now the same distance away from the middle. So the next thing I'm going to do is I'm going to put my dot here on this point. I'm going to draw one little arc right up here. Now notice I don't have to draw the whole circle, because all I need to do is where these two arcs cross, somewhere in the middle. Another arc right there, and that's going to give me a point that's right in the middle of this angle. Once I get that point, just draw it in. Boom. There it is. Angle bisected. Whoosha. Next one. Next one. Same process. The first thing I need 2 points that are the same distance away from that vertex. So I'm going to take my little compass, and I'm going to draw it in. Printer's out of paper. And then I'm going to use these two new arcs. They're going to give me a point. It's right in the middle. Again, don't have to draw the whole circle. A lot of my students like to draw that whole circle. Completely unnecessary. All you need are the points that you're using. So in this case, I need that point that's in the middle. I need my arc line. That's it. That's it. You don't have to draw that whole circle. Don't have to draw it. You can if you want to, but not necessary. So there we go. Both angles are bisected. They look pretty good. We're going to go on to that next page, 42. Bisect a segment using a ruler and your compass. Again, you don't got to use the whole circle. It's not necessary. I'm going to take, and when you set your compass up, you need it to be longer than halfway. Doesn't really matter how much longer. But that way, when you get your two arcs, I'm going to get one arc above, one arc below. Again, not necessary to do the whole thing. Do the whole circle. Put your dot on the little point. There we go. Again, not necessary. Not necessary to do that whole circle. All I want are the two places where these circles will cross. Everything else is superfluous. You're not going to need it. There we go. And it's going to hit that segment right there. And that's going to be the midpoint of my line segment. Use your compass marks. These are what we're talking about with compass marks. Use a protractor to check your work. It should make a 90-degree angle, and it does. Fantastic. Fantastic. Alright. Sliding it up. Two angles form a linear pair. Again, if you don't have a picture, make one. So I'm making this picture. One angle is 5 times the measures of the other. So if this is x, this is going to be 5x. Once I have this picture, 180 degrees for a linear pair. So I've got 180 is equal to 5x plus x. 5x plus x. So 180 is equal to 6x. So x is equal to 30. Once I get to x equal to 30, I can tell you the measure of each angle. This first angle is 30, and the other angle that's 5 times that size is going to be 5 times 30, or 150 degrees. So those are my two angles. This one, the measure of one angle is 24 degrees greater than the measure of its complement. Got to remember that complement is 90 degrees. From one of my students, 1p is like 1/9, so it's 90. In supplement, if I can find it, is there a supplement in here? Supplement has 2 p's. Oh well. Supplement has 2 p's, 2 90s, 180 degrees. So it's one of my favorite ways to remember it. So I know these two add up to be 90. I'm going to draw the picture out. So I've got one angle, I'll call it x. The other angle is 24 degrees larger than x. And they're both summed up to equal to 90. So I've got x plus 24 plus x, my two angles. This sum is equal to 90. Take that 24 to the other side. Now I'm going to get 2x is equal to 66. So I know x is equal to 33 degrees. 24 units larger will be 57 degrees. And those will be my two angles, 33 and 57. We've got a wooden fence. The wooden fence is built around a yard, or a lot rather, is 42 by 80. So the fencing, I'm going to need to go around the whole perimeter. So I've got 80 plus 42 times 2, so 122 rather times 2, 244 linear meters. The fence costs $29 per meter, so I've got 244 meters. I multiply that by 29, and that's going to be $76. $7,076. 46. Now this one I'm going to leave these in pi. If they ask you to go to nearest tenths, make sure you punch it out in your calculator around to the nearest tenth. But in this one, the circumference is just pi d, so just 15 pi, and it's meters. Area is going to be pi r squared, so I'm going to have 7.5 for my radius. So I've got 7.5 squared. Gracious, I'm going to have to punch this. So you've got 5, 25, 37, 35, 52, 5, 2, 6, 5, 2 decimal places, 56.2, we'll call that pi. So 56.25 pi, and that's going to be meters squared for that area. This next one will be easier. Circumference is just pi d, so we'll have 14 pi meters. Again, units important. Area, pi r squared, so I'll have 49 pi, and it's just meters squared for that one. 2 more pages will be done. 48. It's a regular hexagon. This means all the sides are the same. Find x and the side length. If I know the sides are the same, I know that 3x minus 5 and x plus 7 are going to be equal. Pull that x from both sides. We'll get 2x minus 5 is equal to 7. Add the 5. 2x is equal to 12. So I'll get x is equal to 6. And the side length, I put that 6 into either side. I'm going to use this one because it's smaller. 6 plus 7 is 13. Side length of 13. All done with that one. Given a right triangle with a base of 12 and a height of 5, so I've got a base of 12, height of 5. This is going to be a Pythagorean triple. 5, 12, and 13. Your perimeter, you just add it all up. If you don't know how to find that, you can always do a squared plus b squared equals c squared. But it is Pythagorean triple, so we'll leave it alone. 12 plus 13 is 25, plus 5 is 30. The area is half base times height, so 5 times 12 over 2. We'll have 60 over 2, so area is also 30. Sliding it up. Solve this one. Pretty easy. We're going to pull that negative 4 off. That's going to give us negative 19. On this one, solving for y, I'm going to divide the 2 off of everything. That way I don't have to distribute. I'll get 3y. This will cancel. 3y plus 4 is equal to 16. Pull the 4. We'll get 3y is equal to 12. That'll give us y is equal to 4 on that one. Gracious. Didn't have to write that. Onward. Inequalities. This one we're going to want to distribute to 7. Going to want to distribute to 7. So I've got 7x plus 1 is less than or equal to 2x plus 57. Pull the 1 and the 2x from both sides, and I will get, oh, I apologize, that should be a 7. Got to distribute to both terms. Almost missed that one. 5x is less than or equal to 50, which means x will be less than or equal to 10. I like to use 3 numbers on my number line. The one that I'm using, in this case, it's 10. 1 number higher, 1 number lower. Remember that circle is filled in because we can be equal to 10. We're going smaller because we want it to be less than. This one, subtract the 3 from both sides. We'll get negative 2x is greater than or equal to 4. Divide by negative 2. This is going to flip my inequality symbol. So I'll have x is less than or equal to negative 2. Again, 1 number bigger, 1 number smaller. I want it to be less than or equal to, so it's headed in that direction. Simplifying the radicals. I'm going to take and do the factor tree method. You can do any method you like. This is the one I like to do. We've got a pair of 12s, so we're going to pull it out. I've got a 2 stuck on the inside. Did not pair up. 98, I've got 49 times 2. So my 7s will pair up. 7 comes on the outside. This 2 did not pair up, so it'll stay on the inside. 56, 2 and 28, 2 and 14, 2 and 7. So I've got a pair of 2s. They're coming out. This 2 did not pair up on the inside. This 7 did not pair up on the inside, so I'll have a 2 times 7 on the inside. And that will reduce, well, not reduce, that will combine to be a 14. In the 90, I've got 9 times 10. The 10 can break down into a 2 and a 5, but you're not going to get any pairs from that. So I'll have 3 squares of 10. That'll be that final answer. 5 times 2, 10. Last page. Very exciting. We got a lot of true false here. Determine whether or not the following statements can be assumed or concluded. A, B, D, J are coplanar. So I have A, B, D, and then J. D is on this line, which makes it part of plane K. J is on plane K. So this one, yes, you can assume that. EBA is a right angle. EBA is a right angle. It looks like a right angle, but since it's not marked, no, we cannot assume that. Points EGA are collinear. Here's E, G, and A. They don't even look like they make a line on the picture. This one's going to be a no. Line FG is perpendicular to plane K. Here's FG. Here's plane K. Again, it looks like it's going to be perpendicular, but there is no statement that says this is going to be true. My apologies. So that's a no. It looks like it, but there's nothing that says for sure. Then we have angle ABD and angle EBC are vertical angles. Here's ABD. Here's EBC. And they are going to be vertical angles on plane K. Last one, planes H and K intersect at AB. Here's that line AB. Here's H, here's K. Visually they do. We can prove that one. Alright, last part of it. Find the value of x. So we've got a linear pair. We've got 3x plus 48 is equal to 180. Pull that 48 from both sides. You'll get 3x is equal to 132. And then x, kind of have to check this one. X is going to be equal to 44. Doesn't have a y, don't let that fool you. Now this one, you can set these up as linear pairs and go with system, but I'm not going to. I'm going to use vertical angles. I've got 2y plus 15 is equal to 4y minus 2. Distribute the 2. Pull my y's to both sides. I'll get 30 is equal to 2y minus 2. Add the 2. 32 is equal to 2y. Last thing, divide that 2 off. I'll get 16 is equal to y. My x's, same thing, vertical angles. 9x plus 1 is equal to 13x minus 51. Pull the 9 from both sides, and you'll get 1 is equal to 4x minus 51. Add the 51, you'll get 52 is equal to 4x. Divide this off, and you will get 13. X is equal to 13. Alright, last piece. How exciting. Now this one, I'm going to fill out all the numbers, and then I'm just going to answer the question second. So, first of all, it says AE is perpendicular to CG. That makes all of these 90-degree angles. I'll just do 2 of them. ASD is equal to 118. That gives us the fact if this is 90 and the whole thing is 118, that makes this 28. Vertical angles will make that 28. And then the last, and then we'll get you can pull a 62 and a 62 for complementary angles. And then our last one, HSB is equal to 96, so HSB is equal to 96. 96 minus 62, so ASB will give us, 34. And then this one will be 34 because of vertical angles. Complementary angles makes this 56. Once you get all the angles listed, it's just a matter of going through and finding what they're asking you to find. So 66, HSE, we have 90 plus 28. It's going to be 118. FSD is FSD, 62 plus 34 is 96. And those are just vertical angles of the two angles that they give you. BSD, 56 plus 28 is going to be 84. DSE, 62, we have it listed. CSD, 28, again we have it listed. And then GSF, so GSF, 56. And that's it. I would do all the angles first, and then answer the questions second.